Today we're going to be looking at redox reactions, and a redox reaction stands for a reduction oxidation reaction. So it's a combination of these two words, reduction, oxidation. But what is a redox reaction? What are reduction and oxidation? Well, reduction involves gaining electrons, whereas oxidation involves losing electrons. And there's a very easy way to remember this. We can remember it with the acronym oil rig. So we'll swap these back. Oxidation is loss. So the oxidation is the loss of electrons, and reduction is gain. Reduction is the gain of electrons. So this is the easiest way to remember the difference between oxidation and reduction. Now, there's another term I need you to know as well. So let's move these over here. Those terms are oxidizing agent and reducing agent. So the oxidizing agent is actually the substance that is reduced. And the reducing agent, you guessed it, is the substance that is oxidized. So we can find the substance that is oxidized and reduced in a chemical equation, and we can also figure out which was the oxidizing agent and the reducing agent once we know which was oxidized and which was reduced. So let's go ahead and try this. The first equation we're going to try looks like this. Br minus plus Cl2 gives Br2 plus 2Cl minus. So we need to assign oxidation numbers to each of these. You likely are not familiar with the term oxidation number, but the oxidation number just tells us the number of electrons that an atom has gained or lost. So if we see something with a -2 charge, it simply means that atom has gained 2 electrons. And if we see something with a +2 charge, it means it has lost 2 electrons. So it's the charge of an electron, but more specifically, it tells us the exact number of electrons an element has gained or lost. So for this one, it's pretty easy. We see here we have a minus sign. We don't have to worry about this 2 in the front because it was just there to balance the entire equation. So we know Br has an oxidation number of -1. Now Cl2 doesn't have any charge written, but Cl2 is just an element that's by itself. It's just Cl. And any element that's by itself is going to have an oxidation state of 0. So if we look over here at the product side, Br2, this is an element that's by itself, so it will also have an oxidation state of 0. And then here, this one's written for us, so we see that Cl has an oxidation state of -1, an oxidation number of -1. So let's see which was reduced and which was oxidized. We're going to look at Br first. Br went from -1 to 0. So from -1 to 0. If it went from a negative number to 0, that means it had to lose an electron in order to do that. If it lost an electron, that means it was oxidized. So we see here that Br was oxidized. You look here at Cl. Cl went from 0 to -1. 0 to -1. That means it had to gain an electron to become negative. So Cl was reduced. Let's try this again with a slightly more complicated equation. This time we're looking at Mg plus O2 gives MgO. We don't see any charges in this equation. However, we do see that both of the reactants, the Mg and the O2, they're just elements. So assigning their oxidation numbers will be very easy. Mg would have an oxidation number of 0, and O, oxygen, would also have an oxidation number of 0. But what about Mg and O? Well, we can use the typical charges from the periodic table to determine how many electrons they likely gained or lost. And we know that oxygen generally has a -2 charge, and Mg normally has a +2 charge. So we can see here that magnesium went from 0, a charge of 0, to a charge of -2. That means it had to gain electrons in order to become negative. So, in this case, Mg was reduced. For oxygen, we went from 0 to +2. So to become positive, the oxygen must have lost electrons. So in this case, we see that it was oxygen that was oxidized and magnesium that was reduced. I hope you now have a decent understanding of redox reactions, and just one more time, don't forget our handy acronym, oil rig. Thanks for watching.